For module 4, I'm going to give you two different recordings on two different topics. First one is about SQLite, the fundamental basic SQL engine that we will use to introduce you the concepts of how to load or create a database and how to use it. In the second video that I will post immediately following this one is how to use the SQL engine to do your two work outputs for this week. One is the exercise 2 that is due on Friday, April 22nd, and the other one is due on April 24th, Sunday, that is for assignment 2. Okay, so two things, exercise 2 and assignment 2 are due this week, and exercise 2 is due on Friday and assignment 2 is due on Sunday. Both of them will use SQLite. One as a way to create the database server, that is the assignment 2 that is due on Sunday. The other one is basically using already created database, using Python programming, to access the database using SQLite engine, utilizing the package called SQLite3. Okay, so those are the things that we are going to cover. Okay, so here is some key links for you to download the SQLite application, called SQLite3 application, and also understand some basic SQLite3 commands, and then also introduction to SQL Alchemy, which is the package for connecting databases in Python programming. Okay, so these three links you need that. Okay, so I'm giving you that. So using this link, first one, that download, I can go to the download page and download. For example, I'm going to show it to you how to download for Windows, for example. Okay, so this is the page. One moment, I need to bring it to this window. So this download page, SQLite.org download.html, right? The .html will give you this page, but mine is a Windows computer, so, and it's 64 Windows 64 computer, but SQLite 3 is Windows 32 will work. The reason why I'm going to this, a bundle of command line tools, is that this has all the relevant packages and tools and so on. So this is what you have to download for Windows. So go to a bundle of command line tools, right? Use that one, and when I download that, and of course for Mac OS you have to use this one, and for Unix you have to use this one. Okay, so I have Windows, so I downloaded that, and this is what the downloaded package is about. So one moment, so this is the downloaded package. What is the package? This one, I don't need all these things. Okay, I downloaded it twice, so I don't need this, I don't need this, I don't need this, all these things. So I'm going to delete these things, okay, so that it doesn't confuse. So I have one, I have this one. When I extracted that, I get this. Okay, so SQLite tools Win32, same thing, right? I get that extraction, full extraction of this will come out to be this one. And what we have there, I have SQLite tools Win32 x86, and I have SQLite3 engine .exe. Okay, analyze the difference. We don't need to talk about it now. So basically, this is the one that we are talking about, right? So this, if I double click it, it will open the command line tool to work with the SQLite engine, which will create the databases for you, or update the data, create the schema, insert the records, update the records, delete the records, and delete the schema, delete the database, and so on. Everything you can do that using this. Okay, and so if I double click on that one, I actually get this command line tool. Okay, you see this one. Okay, so now the question is, how do I use this one? So okay, so let's go to the next step. So here I'm going to introduce you to assignment 2 first. because it is the order is really the way it is done. I would prefer that assignment 2 is done first, but anyway, at least for explanation's sake I want to use it. So what do I do? What do we do in assignment 2? Let me go to the page. Exercise 2, assignment 2. Okay, not this one. Canvas. Go to the canvas. One moment. Okay. So let's go to the canvas page, and I'm going to go to this our class, that is section 47. And if you look at these assignments, as I said, the assignment 2 is creating a SQL relational database. Okay, so creating the database, first we want to do that. Okay, because that's where the SQLite commands are being used. So I'm going to introduce you by discussing this. I will introduce you the basic commands about SQLite3, because that's what I'm trying to complete first. Okay, and then in exercise 2 we will use that engine, SQLite engine, in the Python programming. Okay, this is not a command line tool. This one is using Python programming. So we need a package. That is what package that connects the Python programming language to the SQLite engine, and that is what is called the SQL alchemy. Okay, and using that you can do your SQL, extraction, report writing, and so on, report creation, and so on. All right, so let's just go to this assignment 2, even though it is due later. So it also does the SQL work. I'm not going to go there first. So what I want to do is know how do we create the database? How do we use basic commands, SQLite commands, to create the database and modify and update and so on. Okay, so we have 2 files there, and this is the database build file, and this one is loading the rows, the data. Okay, this is the build schema build. This one is schema building, and this is actually the data loading, inserting the data. Okay, that's what it is, modifying the data and so on. So when I downloaded this file, and that file is, remember, build db salco. Okay, build db salco is this one. This is build db salco file. You see in the top, right? Build db salco file, SQL, right? So this has commands here, and these commands can be done as a batch processing. We will do that, but look at this, a large one, right? But basically we have created, in fact, this is so it is done twice. It is not only a build process, but also it uploads the data actually, because insert and all coming there. Okay, and there are also computation steps and so on. So take a look at this one. So we are basically creating a table. Okay, you remember the tables are the relations or cohesive collection of attributes, data attributes that go under one name. That in this case create table vendor. Okay, and what are the vendor information? Vendor code, which is an integer, not null, and it should be unique. That's the point, right? So that's the only way it can be a primary key, and you can see at the end it is defined as a primary key. Primary key is V code. So first we define all these things, and then we say what is the primary key. All right. So the V code, the vendor code is integer, and it is not null, and it should be unique among the rows. Remember, when I say rows, it is about the data rows, and columns means attributes. Okay, and then the vendor name, which is a character, and variable number of characters can be there, but up to maximum of 35. Okay, it's a vendor name. Vendor contact information is, it's also character. Vendor contact, vendor name and vendor contact. That means the contact is a person, but vendor name is a organization. So this is variable 15 character max, and it should not be null. It should not be null. Both vname and vcontact and v area code, all of them are not null. Remember, every one of them is not null. Area code is character 3, so it's considered as 3, even though it is area code is a number. We store it as a character 3, and then we phone number. The remaining 8 digits are again read as characters, and then the state is read as characters. Okay, 2 characters, and the order is is read. Vendor order is created as 1 character. Okay, So if you have any questions about this information, you have to go back to the tables. You remember that the tables that we already worked in the previous assignment. That's what is being used here. And in the same way, we want to create whatever the vendor table we had. Similarly, we want to create the product table. Okay, and so we say create table product, and product code is variable character variable number of characters 10 max, and then description is variable number of characters 35 max, and all of them are again not unique, but the code p code is unique, not unique. You remember that. So the only unique codes can be keys. Remember, again, that is another thing, right? The keys have to be unique. And then the product in date is date time, not null. Product quantity of quantity on hand is small integer. So this is to optimize the resources, so small integer, large integers, and so on. Integers, large integers, small integers. So it's not going to be a big number, so that's why we use it as small integer, and it's also not null. The minimum, the product minimum that is that is set for reordering and so on is small integer again. Price is numeric 8,2, that means 2 decimals, and discount is 4,2, that means 2 decimals. In terms of percentages. Okay, and then vendor code is integer. Primary key is P code for here, but then the foreign key is B code, the vendor code, and in this case also references vendor as V code. Okay, so the foreign key V code needs to be connected to the vendor table, right? That's why we say this references vendor, and from there we pick up the V code. So let's say, so we have done vendor code here. So we have vendor code here, we have product code here. So this is called a schema, defining this kind of information for various variables, and the table information is various columns or attributes or variables. I shouldn't say variables, but columns or attributes, and the table name, connecting the table name to those columns or attributes, and their the data types, and what is this is called the metadata. Okay, the data type, and how many columns it can take, all those details is called the schema. So we have defined those two tables, so we can actually ask for what is the schema, and it will just print whatever we entered. Okay, so we can check all those things. So why don't we do that? So for example, let's just copy and paste this one and see what happens. Create in this I'm going to create, I already double clicked here, so here I'm just saying create enter. Okay, so if I ask for dot schema vendor, it will just print what I have entered. So it is to verify what we have entered. That's all. Okay, and so I can also create this one. Let's do that anyway. Create this one. Create the product table now. Okay, that is done. Product table is also done. So again, if I ask for schema, it will just print back. Is there any, what are the constraints? And we want to check all those things. So let's go to the, let's create one more thing, the create table customer. Okay, the customer code is integer primary key, and customer last name is maximum 15 characters maximum, not null. First name is 15 characters, not 15 characters maximum, not null. Customer initial is 1 character. Customer area code is again 3 characters. Default is 615, not null. So if we don't give anything, the default value will be taking 615. Customer phone number is 8 characters, not null, and balance is numeric value 9 positions with 2 decimals, and default value is 0. Constraint is we want to say that the customer name and customer first name and last name and first name uniquely identifies the they are unique. They should be unique. That's what we are saying as a constraint. These things cannot be repeated. So customer UI 1, that's the constraint number 1. Okay, is unique. What is unique? The customer last name and first name together should be unique. And so that is the customer table. So let's run that one also, customer table. And the next one is invoice table. So maybe I'll read all these things and then together we can run it. So the invoice table is invoice number. That's invoice. That's a primary key integer, and it should be integer. primary key. Customer code is integer, not null. And then invoice date is date time, not null. But the thing is, date time refers a particular type of data type. Remember that. And it is the foreign key here is the customer code and references customer data. That's what it says here. Right? Customer code is coming from customer data, customer table. Foreign key is customer code. Invoice number is primary key. Foreign key is customer code, cust_code that is coming from customer table references from the table customer with the name cust code, cus_code. So in the same way, finally, this is the only one left out. There is no line items. So invoice number is not null. We'll have to define what is foreign key, all those things here below. Okay, we'll do that. Line number is numeric, not null. P code, product code is var character 10 coming from the product. Remember that. So in fact, we are saying product code is a foreign key. References table product, and the attribute name is P code. Okay. Line units is numeric. 2 decimal. I think we don't need decimal places. Unit should be integer. Okay, default is 0.00. We don't need to be decimal. But anyway, it's written like this in this code. Line prices. This has to be it can be 2 decimals. So if it is not there, it is 00. So it's not possible. But default value is provided as 00. Okay, just as a definition. Primary key is invoice number and line number together is primary key. Foreign key is invoice number references the invoice table and picks up their invoice number from there. On delete, you'll have it will cascade means once you delete one particular invoice number, it will delete all the items that are connected to that. That's what it is. Foreign key means foreign key P code, product code is references the table product, coming using the attribute P_code. The constraint is that invoice number and product code should be unique. That's what together should be unique. That's line UI1 unique. Okay, that's the name for that. So invoice number and product code should be unique. And in this one, there are indices that we want to create. Indices are useful for optimizing the resources and also accessing with better speed and more arranged, better way of accessing the data is achieved using the index. So what we are saying is that product in date, create index on P_in date, and that is an index P in date X on product P in date. So it's coming from the product table P in date. So P in date is here, right? So that is considered as the that is used for indexing the data. Okay. Create composite index, V code and P code, where vendor code and product code. Create index vendor code when prod X on product V code P code, and we create that composite index. Create index on P price descendant order, to keep it in an ordered fashion with the attribute P price, P_price. Create index prod price X on product, okay, and with the description price and the description. Delete the product price X index. So if you want to delete that, if you don't want it, this is one way. So you created here, but you can also delete it for efficiency. You want to keep only the minimal, most important indices. Okay, so you just say that drop index prod_price X. So now we are ready to insert the data. We created all the tables. We are ready to insert the data. That's what the point here is. So insert into vendor. So we have to insert rows into each one of the tables. Okay, because each table has important purpose in the operations, right? So into the vendor table, we are inserting. Here is the row. The vendor, based on whatever the order in which we read. So let me go back to that. In the vendor code, vendor name, contact, area code, phone, state, order. That is the primary key. Okay, but this primary key is it's part of this V code. So we don't have. You are not inserting data here. You are basically inserting all these data. This. 7 elements. Okay, so let's see. So I go here, and this is the code, vendor code, the name, contact, the company name is this, contact, area code, phone number, Texas, I mean Tennessee, that's what state is TN, and is it Y refers to Y, or yes or no refers to the information whether uh, whether the uh, vendor is ordered or not. Okay, let's take that as vendor as an order or not. So you can see that insert vendor, we create, once we insert the vendor, you can just say select star, and from vendor you will basically get these values. Okay, remember that. So again, I'm inserting the next row and so on, and then similarly we can do any number of rows that are part of our database system. So our their data records we can insert into the vendor, and then we are doing this similar thing, insertion of data rows into product. There are two of them here. You can verify that. So why don't we do that? I'm going to do up to this first, and then I did only one, right? So I'm going to redo one, two. I think I did product and vendor. Okay. So check. We need to do this. By the way, when you do the double dash, double hyphen, then it becomes a comment. Okay, remember that. That's why this will be a comment. Even if I copy and paste, it won't work. Okay, so let me do these things. Done all those things. Okay, up to line. So I basically loaded all the schema, right? Now I'm going to insert this. I can do all this, create and so on, right? I'm not sure whether. Okay, let's do that. We can create indices also. Indices are useful for fast access, and also convenient access also. Besides speed, convenience. Okay, so let's create the indices here. Just run it here. Okay. Now we are ready to insert the data entries here. So as I said, I will just run that also. After it's all done, we are going to commit. Okay, there is a lot of data is entered here, and then select star, product, update table, all those things. So again, I want to show that too. So let's run that part. Okay. Oh, there is a problem here. Not null constraint failed product p underscore in date. Okay. What is the insert runtime error?